So we've been discussing groups in our project because we will need them in order to study the structure of rational points on an elliptic curve. And there's a very simple notion that we haven't mentioned yet, which is the notion of a subgroup. Let's give it in the non-abelian case, in the general case, and it's pretty much the same in the abelian case. So if G is a group, then a subset H is a subgroup. And I'm going to give you the definition that is the most revealing, not necessarily the most concise. Is a subgroup of G if so the identity element belongs to H. So in particular, H is not non-empty. If A, comma B belong to H, then their product belongs to H. And if A belongs to H, then its inverse belongs to H. So in particular, with the inherited structure, H is a group of its own. As I said, there is a much more concise way to express this, and it's pretty much that H needs to be non-empty. And for A comma B in H, A times B to the negative 1 belongs to H. Okay, so pretty much one condition can easily make everything else follow. But I wanted to mention these three conditions because they're a little more revealing about what is going on, which is that what we have is a group of its own. So if we go to some abelian groups to look for examples, so let's say we look at Z, then in Z, for example, we can take the set of all even numbers, and that's a subgroup. Okay, so this is a subgroup of G. In general, we have that the most general description for a subgroup is MZ, where M is an integer. And now, if 2 and negative 2, of course, will give you the same subgroup. And we have the trivial subgroup, which consists just of 0. In general, the group consisting of just the identity element is a subgroup. So this is a subgroup. And in many cases, the notation that we use for subgroup is this one. Okay, so this means subgroup of G. And of course, G also is a subgroup of itself. Usually we're interested in the subgroups that are somewhere in between the trivial subgroup and the also trivial total subgroup, or the total subgroup that we have. And that's all. Thanks for watching.